Okay, class time. Put all your work away. Thursday, we have the written exam on all the math stuff. The way to get ready for that is, let me write that down in the notes. Written exam is this Thursday, the 12th. So the way I try to describe like how you know when you're ready for this exam is you should be able to do all those practice problems and all the example problems that I did in class. And at each step, you should understand why each decision was made, okay? Like, it's not enough, that's to say, like, it's not enough to just memorize the solutions because those aren't going to be the exact problems that are going to be on there. But like, if you can go at every step and whatever was asked about, like, okay, why is this value negative here, and why is this positive, and why are these shears the way they are? If you could answer in detail why each decision was made, you'll be in perfectly good shape. Yep.
Are you gonna be all math problems, or are you gonna have like word problems?
Yeah, let's just do it all calculations. So yeah, nothing like the.
Like you used to give out that little. Like,
that's right. Yeah, so that lecture quiz, I think was what I called it. Let's not do anything like that. So it'll just all be related to doing practice problems and doing example problems.
How many questions?
Probably 2. I'm going to do my best to make it so you don't feel like you're racing, you know. So we have an hour. I'll try to make it so, try to shoot for about 40 or 45 minutes so that like hopefully half the class will be done in about 45 minutes, and then no one hopefully will feel too much like they're racing to finish, you know. It's closed notes and no books or anything, but I'll give you all the formulas that you need. Okay. And if there's a formula or equation or anything that you need that I didn't write on the sheet, just tell me. I probably just forgot it, and I'll write it up on the board or something. Okay. Yes, calculators. And there probably is going to be some kind of principal stress calculation. And if your calculator does it, you can use your calculator. Yeah, if you want to log into MATLAB and you know how to do it in MATLAB, you can do that. Otherwise, I'm going to make it one that reduces to a quadratic equation, so you can use the quadratic formula. So if you have to do it by hand, it won't be a big problem. But you know, it takes longer to do it by hand than it does to do it on a calculator. Okay, so close notes, but all the equations and any constants or anything you need will be given. And it's not going to have anything to do with Creo. It's just going to have to do with the calculations. So like the stress strain type calculations, like the example problem, or like the practice problems. And so today, if anyone has any questions, I'd be happy to answer any questions you have. And then when we're done with questions, I have something sort of like the practice problems, but just something to let you work through this together. And if you took taken my classes before. It's just like the kind of thing we sometimes do in class where I'll give you the problem, give you some time to work on things together, then I'll, solve that part, then we'll go on. So does anyone have any questions related to the test? Okay. So let's go through this problem. So let's say that before deformation, you have a rectangular plate that's fixed to the ground, or fixed to the ceiling, I guess, at the top right corner that's closest to the viewer, okay? And then connected here by rollers. So this point will stay fixed, and if you pushed really hard from the bottom, that would make the sides bulge out. Can you picture what I'm talking about? And that would make the left side of the top move farther to the left. Okay? This would stay where it is because it's fixed. Follow what I mean? Okay, so this point can't move, right? So no matter what you do to this body, this point right here will stay where it is. But every other point along the top is free to slide along the top. Okay, so all it can do is those points can move to the left or move closer to the right, but they can't go up or down. You might be asking yourself, what kind of wheels are those? I've never seen wheels that do that. Yeah, that should, I guess, be like a pin in a slot or something. But that's the idea I'm going at there. And the dimensions. Let me give a coordinate system. So let's say the y-axis is this way, the z-axis is this way. So that's going to make you think a little bit about pluses and minuses with the shears and stuff like that. And the undeformed height is 0.4 meters. Undeformed width is 0.2 meters. And the thickness into the page is 1 centimeter. So 0.01 meters. We're going to neglect the weight. And we're going to say that this material has a Young's modulus of 150 gigapascals, so 150 times 10 to the 9th pascals, and a Poisson's ratio of 0.25. Bless you. And after the deformation, this is exaggerated, but this angle becomes 89.5 degrees. This height becomes 0.406 meters. And this width becomes 0.198 meters. And the thickness stays the same. We don't know what the tractions are that are producing this. That's the kind of thing that we're going to have to calculate, okay? All we know is what the deformation is like. I have one sort of intuitive question here. This is something you would see once you started getting into the calculations. But if the thickness isn't changing, does that mean that there's no traction on the front or the back face? It doesn't mean that. In fact, there has to be in order to keep that thickness the same because of the Poisson's effect. Since we have stretching and compressing in the other dimensions. Those are going to create a bulging or contracting effect in the into the page direction. And for that not to happen, you have to counteract that with some kind of traction on the front and back. Okay, so the first questions, let's do these first two together. First, what's the stress tensor? And second, actually, let's do all of these first three together. Second, what is the principal stress tensor, or what are the principal stresses? And then third, what's the maximum shear stress? Okay, so try to think through this. Talk to each other about it. Don't just work on it on your own. Bounce ideas off of each other, and feel free to ask me questions if you get stuck. But I just want to take a few minutes to let you work through this.